Most training airplanes use four-stroke internal combustion reciprocating engines, which operate on the same principle as automobile engines. A reciprocating engine converts the back and forth motion of the pistons to the rotary motion of the crankshaft. Let's take a look at a typical training airplane engine.
This engine has had several pieces cut away to expose various moving parts. The basic parts of the engine are cylinders, pistons, which are inside the cylinders, valves at the top of each cylinder, connecting rods linking the piston to the crankshaft, and the crankcase, which is the metal frame. Each cylinder has two spark plugs for improved combustion and as a safety backup. Let's take a look at the cycle of a typical four-stroke engine. The process starts with the intake or induction stroke, where the piston is moving in toward the crankshaft. The intake valve must be opened to allow the fuel-air mixture to flow into the cylinder. As the piston starts moving out, away from the crankshaft, both valves are closed and the fuel-air mixture is compressed in the cylinder. This stroke is called the compression stroke. As the piston nears the end of its outward travel, the fuel-air mixture is ignited and the rapid burning and expansion of the fuel pushes the piston toward the crankshaft in the power stroke. During the exhaust stroke, the last stroke in the cycle, the piston moves out and the exhaust valve is opened and the burned gases are forced out of the cylinder. As a cylinder is undergoing this cycle, the other cylinders are each going through different parts of the cycle. No matter how many cylinders an engine has, each of the cylinders will complete the cycle every time the crankshaft makes 2 revolutions. More cylinders will make a smoother engine because there are more power strokes for each revolution of the crankshaft. Burning of the fuel-air mixture produces heat, and much of it is evacuated through the exhaust system. Remaining heat energy is dissipated through a combination of oil cooling and air directed over and around the engine.
Baffles guide and confine the flow of air to the heat-critical parts of the engine. The cylinders have cooling fins, which increase the effectiveness of the airflow. The cooling air enters the front of the engine compartment, passes over the baffled fins, and exits through the rear of the engine cowling.
Engine lubricating oil performs 3 functions. First, it coats the surfaces of all moving parts with a slick film, preventing direct metal-to-metal contact. Second, it dissipates heat as it circulates through the oil cooler. And third, it carries any foreign materials to the oil filter. Because oil is required for both lubrication and heat dissipation, the oil pressure and temperature gauges are important indicators of engine operation and condition. There are 2 types of oil used in airplane reciprocating engines: straight mineral oil and ashless dispersant oil. A dispersant oil contains an additive that suspends contaminants, such as carbon, lead compounds, and dirt. This allows them to be filtered out or drained with the oil rather than deposited within the engine. This type of oil keeps foreign particles in solution without the disadvantages of ash-forming detergent additives.
One last note on engine oil. If you're flying an airplane with a Rotax engine, most commonly found in light sport aircraft, you'll find that it requires a different type of aviation oil. It is commonly referred to as sport oil and is designed specifically for the needs of 4-stroke Rotax engines. Refer to your pilot's operating handbook or engine manufacturer's recommendations for the correct type of oil to use in your engine.
Another reason airplane engines are so reliable is that they have a dual magneto ignition system. The magnetos generate the spark, which ignites the fuel-air mixture in the cylinders. The magnetos allow the engine to operate independently of the airplane's battery and electrical systems, and is one of the redundancies built into the airplane for safety.
As you saw before, each cylinder has 2 spark plugs, and each spark plug is energized by a different magneto. The advantage is safety. If one magneto fails, the engine will continue to run on the other magneto. 2 spark plugs in each cylinder also makes the combustion of the fuel-air mixture more efficient, resulting in improved performance. The ignition switch in the cockpit has 5 positions: off, right, left, both, and start. With the switch in the left or right position, the engine is running on only one of the magnetos and only one set of spark plugs. When the switch is placed in the both position, both magnetos are supplying ignition and all spark plugs are firing. During engine run-up, you'll check both magnetos to be sure they're operating correctly. Check your airplane flight manual or pilot's operating handbook for the correct procedure for your airplane. Remember, always place the switch on both for flight and to off after shutting the engine down.